Good afternoon, sir.
Good afternoon, ma'am.
Welcome all the participants to the another session of Professor Dr. P.S. Rana. As he has already discussed the topic for the day, so I am handing over the session to sir. So please.
Thank you, ma'am. Good afternoon, all of you. So just wait for, let's suppose one more minute. Then it's only 33 participants right now. So for the time being, kindly download the workshop content from this link. So this link is case sensitive. Just write the link in the, I just copy the link in the chat window also. So just wait for one more minute, then we will start. Okay, let's start. So in this session, I'm going to cover the PyCaret package for regression and classifications. So these are the two Python notebooks that are also stored in this link. So you can download all the available Jupyter notebooks from this link. So today I'm going to cover about regression and classification. And there is another session tomorrow in the morning, I think 10 or 10:30. Tomorrow I will discuss about classification part, clustering part, and some important resources that may help you in your research. So today's topic is PyCaret for regression and for classification. So let's start. So PyCaret is a very new library available in Python. It just recently 1 year back, and it is an open source and automated library for Python machine learning. Now, class, the environment that I'm using, that is known as notebook, Python notebook, or it may also known as Jupyter notebook. So if you double click in the environment, so you will find some code like this. It is just similar to your HTML code. So you may use, if you press Control Enter, it will appear like this. Okay. So those who don't know how to work on the Jupyter notebook, it is very easy. Now the link that I give you in the workshop content, from this link you can download all the Jupyter notebook that I already run. Now, this is only 3-step process to build machine learning models for classification, regression, and clustering. Means within the only 3 steps, we can build machine learning models and we can compare multiple models. There is a self-running resource you can explore. There is a manual for regression and tutorial for PyCaret. So you can already explore these resources, these PyCaret libraries at their own. Now, very first step to install Python library, there are 2 ways to install: Anaconda or pip. Okay, so just write conda install PyCaret in the command line argument. It will automatically install the PyCaret library in your environment. So there are 2 ways. If you are working in Anaconda at the command line, so just write Anaconda install PyCaret, but internet should be connected so that it automatically download and install in your machine. If you want to install through this notebook, then just put exclamation sign before the command. Okay, so this is the way to install the PyCaret. If you cannot install from using these command line, then there is an online manual is also available there. You need to create your environment, you need to activate. So this is a very good tutorial to install your environment manually. So today we are going to learn how to get the data, how to set up the environment, how to create model, how to tune, plot the different models, finalize, predict, and how to save and share your models. So these are the things that I'm going to cover today. So let's start. So very first is regression. So this is an example of regression. Now, So come to 1.1 step, data loading.
ఓకే ఇక్కడే ఉంటుంది పక్కనే
ఇంకొద్దు చూడదు చదువుకో క్వశ్చన్ చదువుకోరా ఏంద్రా ఈ రోజంతా అయిపోయింది కదా 10 minutes ఇవ్వడం చాలా ఉంది
Please mute your mic, please. Ma'am, please mute your mic.
ఇది ఏ మెయిల్ తో అడ్రస్ చేసావు
Ma'am,
ఇది కాదురా నాయన కాదు ఇది పద్మజ నేను చెప్తూనే ఉన్నాను వినవా అది పద్మజ.j2e
ma'am, please mute your mic. Padmaja, ma'am. Dr. Padmaja.
దాని పాస్
Okay, ma'am. So class, very first step is data loading. So there is a library known as pycaret.utils. Now it will only work after the installation of pycaret library. Okay, those who are new to Jupyter Notebook, I am suggesting you kindly start working on Jupyter because the interface is very easy. You can store intermediate result. You can share your executed result with anyone. So to execute a command, you need to just press Control Enter. So just click it, press Control Enter. It will run and it will give you the version. So presently I am using 2.2.1. That is the latest version of pycaret. So this is the way to get the pycaret version. You need to import util library from pycaret and import version. So that is a function name that give you the version of the pycaret. Now, I already executed all the each and every command for you so that time will not waste. So next step is loading the data set from pycaret. Pycaret already contain multiple data sets that we can use for regression and classification. Okay, so from pycaret.datasets import that data. So that is a function that we are going to use to get the data information. Okay, so just press Control Enter. Now next, let's suppose we want to know how many data sets are available with the pycaret. So just use get data and pass the index. If you pass the index and just print it, so you will find there are nearly 55 machine learning data that are available. Okay, so now this is a classification. Let's say for default, what is the default task? The default task is for classification binary or clustering you want to perform or regression you want to perform. So that is a data set that available in the pycaret package. Now today we are working with Boston data set. So let's start. So that is a way to get all the data set available in the pycaret. Come to next step, get the Boston data set. So now this is a simple thing, get data Boston. So we need to just pass the variable name. Let's suppose we want to work on Titanic. So just pass Titanic. Okay. Now after that, this is a function that used to extract the data and assign to the data frame known as Boston_df. Okay, now it is just read the data set. Now let's suppose you want to work with your own data set, then you need to write the code here. Here Panda will be used to read the CSV file. Okay, let's suppose you want to work with your own file, own data set, then you need to just read your file with pandas. Okay, now the thing is that you need to write like this only. Let's suppose you import the panda as pd dot read CSV and let's suppose your file name myfile.csv. Okay, so if you want to work on your own data set, then you need to read the file like this only. Okay, and before that you need to import pandas as pd. Okay, so I think ये सभी को समझ में आ रहा है, everyone is getting. So now when I read the data set, so this is the number, there are number of columns and number of values. So the last part, MEDV, is my target column. Okay, and now you can clearly see all the target column are of continuous values, or you can say the decimal values. So that's why this is my regression data set. Okay, now take an example of red. So this is discrete, either 1, either 2, or either 3. So that is known as discrete, mean countable. So in that case, if I create, red become my target column. In that case, this data set is of multi-class classification. Okay, so now for the time being, I am dealing with the regression data set. So just view the MEDV column that is of continuous value, means that this is a data set of regression. Okay, next, there is a function with the name dot shape. Just want to know how many number of rows and number of columns are there. So 506 rows are there and 14 columns are there. Next, remove duplicates. So class, I'm requesting all of you, before starting any machine learning model building, first read the data, and just in the second step, just remove the duplicates. So there is a function with the name drop duplicates that automatically drop all your duplicates. So now this data set does not contain any duplicate value. So that's why before and after removing the duplicate, the number of rows are same. Okay. So that is the very first step, reading your data set. Now in the next step, 1.2, setting up the parameter for regression models. So we are going to set up the parameters. Okay. So in this parameter, we can set what is the train test division, sampling, normalization, transformation. If we want to apply different PCA, handling of outliers, feature selection. So these are the things we can easily perform with our data set. So now, so from pie_regression. So class, this is the way we need to extract all the regression models, okay, that are available in pie_. Import star. Okay, so that is the library you need to import, and in this function setup. So this is a setup function. It requires two default parameters. Number one, what is the data set? So that is the file, that is the data set, data frame that just read earlier in the above code. Next, we need to define the target column. So you can see MEDV is my target column. So we need to define two things. Number one, what is the data source and what is my target column. Okay. So when you run this code, a default parameter are set. So there are long list of parameters that it automatically sets. So 55 parameters are there. Okay. So now, if you want to know more about setup function, just click in the function and just press Shift Tab. Class, just remember, you need to just press Shift Tab. Okay, let me execute this code. So if star is there, means it is busy. Okay. Let me run the code again. So now when we run the setup function, it asks for input. It waits for some input. So if you are agree with all the numbers, all the parameters, just press enter, else you can change. Okay. Now I'm talking about the help. So just click in the setup function, press Shift Tab. As you press the Shift Tab, you find a small windows appear. Just click on press. So you can clearly see what are the different other parameters. Okay, I will cover all these parameters later in the program. But just pressing Shift Tab, you will find there are a lot of other parameters that are set default. So some are true, some are false, some numeric values are given. So these are the default parameters that are set up for this setup functions. Okay. If you explore more, if you go down, you will find all the parameters are explained in detail. Okay. So you just remember, press Shift Tab. Done. Now next. So this is the second step. We need to set the parameter. Now in the third step, we need to run and compare the performance model. Okay. So now this is a simple function, compare underscore models. This is a function and just run. Okay. So let me run this code. So now it is running. So there are nearly 14-15 regression models are available. Okay. So these are the models. Now it is producing some results. Okay. Now by default data division is 70-30. Okay. So that will compare and that is running models. Now all the models that are available in PyCaret, it uses from scikit-learn library. So if you don't know about scikit-learn library, just go to and explore what scikit-learn library is. There are many machine learning models are available individually. So what PyCaret did, it make a complete bundle for different machine learning models. So just calling a simple function, compare models, you can run all the machine learning models, all the regression models for your data set. So just give me one or two more minutes. It is still running. Now that is the final result. So class, gradient boosting regression, GBR. So it performed very well. So you can clearly see that it will compare nearly kitne models hain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19. Now, it compared 19 regression models on these following evaluation parameters, like mean absolute error, mean square error, root mean square error, R square, and these are the two other parameters. Okay, so now you can clearly see that GBR and cat boost perform very well because their R square is value is quite high, 0.85. Okay, now these parameters are calculated on testing data set. Okay, so now class, when we are writing the machine learning models, when we are writing the research papers, we need to give this type of comparison. So now it's make the implementation of machine learning models very, very simple. Okay, without knowing anything, you can easily compare which model is performing very well. Okay, now in this comparison, my GBR model is performed good, so I can use this model for the future predictions. Okay, so is it clear for all of you? Kindly write your answer in the chat. Are you getting something? Or if you have any question, you can also ask, or you can write in the chat also. Okay, very nice. Okay, good. Okay, now move forward. Okay, now class, after comparing all the models, okay, now let's plot the model. So let's suppose in this experiment we find GBR and cat boost are the outperforming models. So let's plot some plot. So very first is residual plot. Okay, so now I am creating a model. Create model is an inbuilt function. Then just pass the cat model, cat boost. Now what is cat boost? So these are the synonyms, these are the short form of the models that you want to run. Okay, now most common models are like linear regression, random forest, decision tree, okay, and KNN. Okay, now so I just create a model cat boost, and there is a function with the name plot model. So cat boost model is the variable name, that is this model, and plot residual. I will cover all these things in the detail, but I am just giving a brief about what exactly we can produce, we can generate, we can plot. So that is a residual. It clearly shows that R square value for my training data set and my testing data set. Okay. Next plot is known as scatter plot. It is also known as error plot. So that is the R square value for testing. So everybody know okay, what scatter plot is. It is plot between actual and predicted on the testing data set, and R square value is 0.89. Okay. So now what exactly I did? Just pass the parameter plot equal to error. It will automatically plot scatter plot. Done. Next, learning plot. So now next parameter is learning plot. So just change the parameter plot equal to learning. It will give you the learning plot. Okay. Now all these plots you can use in your research paper so that reviewer will attract ki, haan, you did something. Next, there is also one more plot known as validation curve, but it will take 5 to 6 minutes. So, but just uncomment it and run. So it will also produce one validation graph for you. Okay. So now this is the 3-step process to compare 19 classification regression models for your data sets. Okay. Now let's move forward to apply some other pre-processing part in our data set. So now come to point number 2, part 1. So very first is data normalization. Let's suppose you want to run machine learning models and want to know how the models will perform when I normalize the data set. Okay. So now class, this is very, very simple. In the setup function, if you press Shift tab, you will find normalize. So now what I did, normalize equal to true, and which normalization method I want to use. Okay, everybody knows what normalization is. So the most common is min max. Okay, you divide all the column with the maximum value, and all the value will be come between 0 and 1. Okay, that is considered as a minimum most commonly normalized method. Now, if you just explore, just press Shift tab. Okay, just press plus and just come to the parameter known as normalization. So class, by default it is false, and if you make it true, so by default normalized method is z-score. Okay, now if you come forward, move down, and you will also find what are the other normalization method available. So now normalize equal to false. Now these are the other methods. Very first is min max, max absolute, robust. Okay, so these are the other normalization method. So you can easily change the method. Now when I run the code, so I set up the parameters and compare the models. So these are the two functions you need to call. Okay, so now, so I get GBR, R square value is 0.85. So my GBR again perform very well. Okay, next is XGBoost boost, but in the early example we find cat boost is on the second place. Okay, so there might be a possibility that there is some difference in the performance. Okay, so now just I do two things. Number one, normalize equal to true, and normalization method is z-score. Let's suppose you want to apply min max. So just copy and change the parameter to min max, and just press Control Enter. It will execute and it will perform the data normalization and run all the 19 models. Okay. Next, come to 2.2. Let's suppose you want to apply feature selection. Okay. Now I want to apply feature selection and I want to know which model perform very well. So just feature selection equal to true. Now these are the parameter name. Okay. And I make it true. After make it true, I want to use the threshold feature selection. What will be the threshold? So class, basically, if you know feature selection, so there is a curve known as bell-shaped curve. No, not in the bell-shaped curve. So feature selection is that it uses Pearson correlation. So there are 14 features, and every feature is calculate the Pearson correlation with the every features. Okay. Now it will keep all the parameter, all the features whose correlation is less than or equal to 0.8. Means if the correlation between the two variables is greater than 0.8, it will drop 1. Because what happened? If the correlation of two variable are same, means 0.8 or above than 0.8, means both the variable are same. So there is no use to use both the parameter that having the same value. Okay. So you can also change the threshold to 0.85, 0.9. Okay. So it will drop all those columns, those having the Pearson correlation greater than 0.8. Okay. So now after applying the feature selection, I'm getting ET is outperform. Okay. Also, you can apply multiple pre-processing simultaneously. Let's suppose in the earlier example, we apply normalization. So what you need to do, just copy, means you need to apply normalization with feature selection. So just make normalization true, normalization method, feature selection true, feature selection methods. So this is the way you can apply the pre-processing part, very simple to for the different machine learning models. Okay. Now that is the ultimate objective, which pre-processing technique we should apply so that our model give the best performance. So now right now we are getting the R-square values 0.86. Now if I am asking the same question to you, okay, how you can improve this 0.86 to 0.9, what other method, what pre-processing technique you can apply. Okay, so now this is all about feature selection. Next is outlier removal. Class, everybody knows what outlier is. Outlier is the extreme value. Let's suppose this is a data frame. Extreme value means on the positive side or also on the negative side. So there is a bell-shaped curve we generally plot for the data distribution and we remove. So now what I did here, remove outlier equal to true, and there is a threshold for outlier, means 0.05, means 5%. So 5% from either side, negative values as well as positive values, just remove those values. Okay, you can also change this to 0.1. So 0.1 means we are discarding the 10% from either side. Okay, so after applying the outlier removal, you can find that ET extra tree regressor will outperform, and the R-square value is increased to 0.87. So I think this is the highest R-square value that I got it. Yes. Okay. So I hope everybody is getting how to apply the different pre-processing technique. Please write your answer in the chat. Are you getting, or I need to explain more? Please write in the chat. Okay, good. So now next, let's suppose we want to apply transformation. So class, now if I am asking a question from you, how we can improve the performance of our model. Okay, so there are two answers. There are two methods are there. Number one, tune the model parameters. Okay, there are models, there are the different parameters for a model, tune them, or you can apply pre-processing. Okay, pre-processing means applying normalization, removal of outlier, feature selection, apply your transformation. So these are pre-processing techniques. So there are two methods through which we can improve the performance of the model. Very first is tune the model parameters, means change the number of hidden layers, number of trees, or any other method in the function. So this is the one way, and second way is pre-process the data. Now next is transformation. So class, transformation means, let me explain transformation. Let's suppose we have some data that is vary between 1 and 100. Okay, there is a one column, and that having the value from 1 to 100, every value, every column. Now what I did, if the value is greater than 1, between 1 and 20, I put 10. Okay, if the value between 21 and 40, I put 30. Okay, if the value between 41 to 60, I put 50. So I summarize all the values in the 4 or 5 values only. So that is the example, one of the example of transformation. Okay, you can use anyone. Okay, now, so their transformation, make the transformation true, and that which transformation method I am using. So there is a Yeo Johnson. Okay, so this is one of the transformation method. Now after running this, applying transformation, we can find that cat boost model is outperformed. Now this time we find that R square value reached to 0.9. Okay, so now that is the highest one. Okay, now till now. Now we can also apply different transformation, combination, permutation of different all the features in the same functions. Okay, so you can also apply other optimization algorithm to find the best parameters, means best set. Okay, applying transformation yes or no. So those who are familiar with the genetic algorithm, they can use with this function, okay, apply yes or no. Okay, find the best combination that perform that high, that maximizes the R square value. Okay, next, PCA. So class, most of you know what PCA is. So let me explain in a layman language. PCA is known as principal component analysis. So let's suppose you have a large number of features. Let's suppose 40,000 features. Earlier, when we work with the image processing, so that consists of huge amount of number of rows, number of columns. Okay, so 40,000 features is too large. No model will able to work on 40,000 features. So what PCA did, PCA normalized, reduced the number of sets in a 3 or 4 rows, 3 or 4 columns. Okay, so now what will be the effect after applying the PCA? So now how to apply the PCA is that make the PCA true. PCA method is linear. Okay, I also apply transformation true, transformation, which transformation method I used. So now after applying PCA with transformation, we can find that R square value is reduced to 0.43. Okay, so you need to make the changes in the data set, and you need to make the performance, because no one in the world, they can easily just see the data and you can use this model. This cannot be happen. Okay, you need to run the model. Okay, so this is the way to apply the PCA in your data set, and you need to check whether its performance improves or not. Okay, so this is all about applying the pre-processing part. Now the third part is how to run the single models. So come to part number 3, that is regression advanced part 2. So now let's suppose we want to run a single model. How to do that? Okay, so now class, create model. So if you click and if you run create model, you will find a help. So just press create model. So this, now you will find the shortcuts for every model. Let's suppose I want to run linear regression, then you need to pass LR. If you want to pass lasso regression, then you need to pass lasso. Now this time I am running cat boost, so that's why I pass just cat boost. How many times you want to run, that is k-fold. Okay, so just call a function create model cat boost. Okay, so just run it. You will find it will run for 10 times, and in the end you will find the mean and you find the standard deviation. So after running this function, we find R square value is about 0.37. Okay, next, so these are some shortcuts if you want to perform, you want to run individual models. Okay. Now next, perform tuning the model. So class, tuning the model means I need to pass regression model cat boost, the same model that I created earlier. This is the model name that I created, cat boost model. So there is a function with the name tune model. Now the model that we created earlier, we want to tune, means we want to find the best number of parameters. Okay, so we pass the train model, how many number of iterations we want to perform. For the time being, I run for 10, but you can run up to 50, you can run up to 100. Okay, now we need to define which optimize function we need to apply for. Means we want to minimize mean absolute error. You can also use R square. You can also use mean square error. Okay, now it will run for 10 iterations. End of the day, we find the R square value is 0.39 because we'll run it for low number of iterations so that it will run faster. But I am requesting all of you, you can increase the number of iterations. So tuning the model improve the performance. Okay. Next. So till now we build a model. Next step to save the train model. That is very important. Let's suppose you train a model and you want to perform for the new object, prediction for the new object in the future. Okay. Now let's suppose after 2 days or 3 days. Now there is no need to retrain the model. Just train the model and save to the file. Okay. Save to the file so that in the near future, when we require for the prediction, just load it. But before loading, we need to store the data, save the file. So now there is a function with the name save underscore model. Okay. So now this is a tune model that I created earlier. Now this is a tune model. Okay. Now after that, give the file name. So I give the file name cat boost model. So as I run the model, it will save automatically in this file. So this is the file name. Okay. The extension is PKL. So PKL is pickle file. Okay. So now my save model is saved in this file. Now I can share this file with you, or you can share your train model with me with this file. Okay. So this is a step to save our model. Next, let's suppose I mail you a model or you train a model and you send to me. So now very next step is to load the model. So there is a function with the name load underscore model. So this is the file name without extension. Okay. So when I run it, it will load it in this variable cat boost model. Okay. So now I have the train model. In the next step, let's make the predictions on the new data set. That is the ultimate objective now. We save the model and now we load the model. And now loading a new model. Now we are going to use this model for the new data set, prediction of the new data set. Okay. So now very first step is to load the data. Okay. That data must be new. But for the time being, I am just using the same data set on which I train the model. So I assign to a data, Boston data set. So I use only 10 columns and I assign to new data. So these are the 10 columns, means my model will use only the dependent input features. It will go to the model will make the prediction and it will give you the new MEDV. Okay. So now this is the data set. I just extract 10 rows so that we can interpret the result, what exactly going on. Next, make the predictions. So there is a function with the name predict model. Okay. So this is the model name that I loaded through the train model that I loaded from the read from the file. Now this is the data set. This just I read recently that contain only 10 rows. So this is the thing. This is the function through which we can use for the prediction of the new data set. So this is a new predictions. So now a new column with the name label will generate, and this model is generated. This label is generated. These values are generated through the train model. This is the same train model that I used, I stored in the file. So now let's suppose for this input, just ignore this column. Okay, just ignore this column. For the same inputs, this is my MEDV, new predicted model, new predicted values. So you can clearly see that almost all the value are having the similar values. Okay, because the same model is trained on the same data set and it's make the prediction on the same data set. So value must be almost similar. Okay, so this is the way we can predict for the new data set. Done. Next, let's make the prediction. Let's plot the scatter plot. So this is the code. I extracted the actual, I extracted the predicted. Okay, I make the plot. So this is my actual versus predicted plot. Okay. Next, save the result. So now let's suppose I want to save this value to a file. So variable name dot to CSV, and you need to give the file name. So it will store all the predicted values result to this CSV file. Okay. So class, till now I hope everybody is getting what exactly I did. Yes or no? So you can run only this code only when you start working on the Jupyter notebook. If you know very well how to work on the Jupyter notebook, then this is very easy for you. So if you don't know how to work on the Jupyter notebook, just there are lot of videos available on the YouTube. Explore them and just do what they are following. Okay. Next. So class, now let's plot the models.
Okay. Sorry to interrupt you, sir.
Yes, ma'am.
If you have any Kaggle account, could you please put in the chat box so that we can avail the code later?
I also put
just
the code
for practice purpose.
No. I also provide you the link now. This is the link.
Okay, okay, sir.
So just let me paste again. So that is the Google Drive link. You can download all the PPTs and Jupyter Notebook from this link.
Thank you, sir.
Okay. Now, so let's suppose we want to plot the plot that we already plot. Let's suppose error plot, residual plot, learning rate, features, parameters. Okay. So now how to do that? So first I created a random forest model. Okay. So to create a random forest model, create model RF. Okay. So it automatically creates the random forest. So you will find the R-square value is average R-square value is 0.36. Okay. Now let's suppose plot residual plot. So that is a residual plot. Okay. Now this is my scatter plot between actual and predicted. So we need to just use the function plot model and plot error. Okay, just pass the error. Next, this is known as distance plot, also known as Cook's distance plot. So I don't know exactly what it is, but this is one of the Cook's plot. You can also use, you need to learn yourself what is the significance of Cook's distance. So this is a plot, but that help you need to put these plots in your research papers. But at least you need to write two, three lines about what exactly this plot is. Okay. Next is feature selection recursively. It will take 3-4 minutes. So plot equal to RFE, recursive feature selection. Okay. So it recursively deletes some features and retrain the random forest. Okay. So I am not running this code because it will take 3-4 minutes. Okay. Next, learning curve. So this is all about learning curve. Next is validation curve. Yes, earlier I missed this plot, so I run this plot for validation curve. Okay, so you need to just pass VC. Next, manifold. So manifold, this is also one of the plot. Okay, how exactly when we are using three features, how our prediction is look like. Okay. Next, hyperparameter. If you pass the parameter, you can clearly see what are the parameter I used for my random forest. Okay. So now there is a plot for if you know about random forest. So there are a number of we need to the most important part is number of trees. So here number of tree I use is 100. Okay. Next is feature importance. So class, this is one of the important thing when you work with your data set. Reviewer may want to know which is your most important features and which is your least important features. Okay. So now for plotting the feature importance, just plot the model. So for the time being, I train a cat boost model. Okay. And I plot the model and pass the feature. So it will plot all the important features. Okay. What are the component 1, 2, 3? So these are the important features that we can use for my my model. Again, I am plotting the feature using different models. Okay, I choose only those models that perform top five models that outperform during my experiment. So top five models are this one. So I use GBR, Cat Boost, XGBoost, ER, ET, and RF. Okay. So what exactly I am doing? First, I create the model and I just plot. So these plot will help you to find the features, important features for your work. Okay. Now, how exactly we need to use this one? Let's suppose you calculate the feature importance using 5 models. Okay. Because if you're running another RF, it will give different features. If you're running linear model, it may give different features. Like in this example, component 1, component 3, and component 2. But in the other example, if you use GBR, you will find component 1, 2, 3. Now, class, my column name, my feature name contains spaces. My feature name contains spaces. That's why it's give underscore. So we cannot correlate which component is related to which feature. Okay. Now this will I will explain you in the when I work with the classification. So it will show clearly which feature is important. Okay. So now let's come back. Let's suppose you calculate the feature importance using 5 machine learning models. Perform good models. Good model means whose R square value is above 0.8 or 0.75. Okay. No need to consider the perform that give the R square value 0.3. Okay. So let's suppose 5 models are there. Take the average from all the models. Then you can choose. Then you conclude these are the sequence of my feature importance. Okay. Because rather than depending on the one model, it will not give you the feature importance. Like this example, if I run XGBoost model, if give component 1, component 3, and component 2. Okay, but still component 1 is best in all the model selection. Okay, so this is the way you can plot feature importance, and you use these plot to your research papers also. Now, the last part is deploy the model in AWS. So class, AWS is Amazon Web Services. Let's suppose you want to create a web service of your data so that other person can also use that. So this is some manual you can use. But the self-learning resource is very, very important. So just let me give you a brief summary for the regression PyCaret. So class, in the tutorial part, there are again some very good resources for regression, classification, and clustering. Okay, so this is the thing. So it is also contain anomaly detection, NLP, association mining. So I'm requesting all of you kindly use these resources and try to learn at your own. Next is regression models. So that is in the homepage of PyCaret. So all the things that I explained, it is clearly written and with the example in this web page. Okay. So I am requesting all of you kindly go through these resources. These are very, very important. Done. So anything about regression? Any question, query? Because nowadays, machine learning model, building a machine learning model and comparing the machine learning model is not a big deal. Okay, I teach this course to my BTech second year student, so they know how to train the model. But the important thing is that on which domain you want to apply machine learning. Okay, the session that I covered in the morning, okay, how to generate our own data set. Let's suppose you generate your own data set at your own, then that is the important thing. Okay, otherwise what exactly we are doing? We get the data from Kaggle or UCI library, build the model and compare and just maximum tune the some models and just show that this is the model. Nowadays, this is not a big job. It is just a matter of 5 minutes. Okay, and my BTech first year student or even second year student can do that. The thing is that how to get the data from different domain. Okay, so your maximum focus is on the domain part. Create the feature, find the new feature, generate the new features. Then after that, you need to apply the machine learning models. Okay. So any question about the regression? Okay, now let's move to the other part, classification. Okay, so now again, the same thing is that, so for the classification, there is a manual and there is a PyCaret package. So this is a tutorial for the classification. Okay, and that is the PyCaret official documentation for the classification models. Okay, so you can explore these tutorial and manual. So now let's start classification. So this is the way to install the same thing. Now this is the live version. 90% things, 95% of things are same. Only 3 and 4 lines are changes for the when we are evaluating the models. Okay, so if you will find 99% same. So that is a version. Loading the data set. If you pass the index, it will show you the different data set libraries. Okay. Next. So this time I'm working on diabetes data set. So there is a data set with the name diabetes. Yes, diabetes. So class, you will find there are 768 rows, 9 columns. Okay. And this data set is of classification binary. Binary means, so first I read the data set, diabetes, and the last column, class variable, is my target. And you can clearly see that it is binary classification. So value is either 0 or 1. Okay, so now let's start working on this data set. So now to get the shape, dot shape variable is there. It will give you 786 rows, 9 columns. Now, very first step is to remove the duplicates. So again, there is no duplicates. Okay, so this is a step number 1 to read your data set. Next, 1.2, set up the parameter. So this time we are importing PyCaret.classification. Okay, earlier in the regression, PyCaret.regression are there. Okay, the same function setup is there. It required 2 things. Number 1, data set, and next is target column. Okay. Now, one important thing is there. Let's suppose you want to run the program. You want to run the models for number of folds. So by default, it is 10, but you can change here for 20, 25, 30, 35. Okay. So now after running, it may ask, are these parameters okay? Just press enter. Okay. So now this is step number 2. Now step number 3, you need to call compare models. Just press Control Enter. Okay. So it will run. It will take 3-4 minutes, and it will run nearly 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, it will run 15 machine learning models for you. Okay. It will run 15 machine learning models for you. and you will find rigid classifier perform outperform. Okay, so now this is a 76% accuracy. So class, in the classification and in the regression models, the evaluation parameters are different. Okay, because in the classification, specifically in the binary classification, there are two terms. Number one, sensitivity and specificity. So let me explain in a very simple or layman language. Sensitivity means one, if the value is 1 and my model is able to predict the value 1, means 1 ko 1 predict karna, it is known as sensitivity. Now means if my patient having the cancer, if my patient is having the cancer, my model is also able to predict, okay, now you have the cancer, means 1 ko 1 predict karna. Okay, now talk about specificity, means 0 ko 0 predict karna. If my patient don't have the cancer and my model is also able to predict it having no cancer, so this is known as sensitivity. Okay, means 0 ko 0 predict karna, it is known as sensitivity. Done. So now we have accuracy, we have AUC curve, recall, precision, F1, kappa, MCC. So these are the evaluation parameters, and the most important thing, we need to maximize all the parameters. Okay, so now so this is a 3-step process, and remaining all the processes are almost same. Now very best is plotting the model. So let's suppose I want to plot linear model, we want to plot AUC curve. So just pass AUC, it will plot AUC curve for you, okay, for the linear regression model. Next, precision recall curve. So just pass PR, use the function plot underscore model. Next, this is the most important thing, confusion matrix. So plot model, you need to pass the model name and you need to pass confusion underscore matrix. So class, confusion matrix is that, let's suppose this is true class, matlab actual, and this is predicted, means how many times if the value is 1 and my model is able to predict at 1, okay, that is 55. If the value is 1 actual mein, then model is predicted as 0 28 times. Similarly, actual value is 0 and my model is able to predict 0, means 125 times. Okay, so this is known as confusion matrix. Now next, error plot class wise. Okay, how many errors is there when there is a value for 1 and when the value is for 0. Next is class report. Okay, so what are the different parameters we consider? Precision, recall, F1, support. What are the different errors are there? Next, boundary condition. So just call the function plot model, pass boundary. Okay. Next, learning curve for the model. So again, the feature importance. Now class, this is important thing. Here it is giving you the best value, features name also. Okay. So now just provide the model and pass feature. So it will give you all the features that having the maximum variable value. Okay. Now let's suppose if you want to plot all the features. So you need to just pass feature underscore all. So it will give you all the features with their importance. Okay. So this is the most important features. Number of time pregnant 2, and this is the least important features. Okay. So this is the basic thing about for classification using PyCaret. So that will make your life very easier. So class, do you have any question till now? Any query?
No, sir, we are getting. Thank you.
Okay, very good, very good. So now move forward. So now again, the same thing. Let's suppose we want to perform pre-processing part, applying normalization. So just make normalization true and normalization method z-scores. So again, we run and you will find the cat boost model is outperformed, giving the accuracy of 76%. Okay. Now next is model performance using feature selection. Okay. So now just pass feature selection equal to true and feature selection threshold is 0.8. Okay. So this is the way you can apply feature selection. Next, outlier removal. So again, the same thing. Just make the outlier underscore outlier variable equal to true and outlier threshold equal to 0.05. Next, transformation, the same thing. So this is the way you can apply different pre-processing techniques on your data set, and you can easily compare which model gives the best performance. Okay. Now same thing you can apply PC also. So this is all about applying pre-processing part. Now next, the same thing I also covered, running a single model. So you can easily run the model again. So I'm skipping this part. Yes. So we are done with the classification part. So this is all about running all the models in a single go. Okay. So class, you can also find some good tutorials on YouTube. Okay. So you can also explore over there. But the 90% things I already covered in the small tutorial. Okay. So now I'm requesting all of you, don't focus on the machine learning model building. Focus on the data generation part. Okay, how we extract the feature. That is important thing. Okay. Or how we are generating the new feature by combining the multiple features. How we are selecting the best features. Okay. So now it's hardly a matter of 5 minutes. You can compare different machine learning models on different parameters. Okay. So this is a thing. So if you have any question, query, you may ask. Okay, no issues. So tomorrow class is very important. Tomorrow I cover 3 topics. Number 1, clustering. Number 2, what are the different resources? And number 3, TOPSIS. TOPSIS. TOPSIS is a multi-decision criteria making technique. Okay, so that is very important. Okay, it's hardly a matter of 2 minutes, but you know very well what TOPSIS is. Okay, so you can use TOPSIS method in your research also. But tomorrow class is, I think, at ma'am कितने बजे है class है कल?
Sir, 10 o'clock.
Okay, so tomorrow class is at 10 o'clock. So kindly join before 10 so that I will cover these 3 topics in detail. So if you have any question, is scikit-learn also useful? Yes, Rinki Gupta, it is also useful, but you need to install and run each library again and again. But if you are working with PyCaret, all the packages, all the library are also installed, and you can compare all the model in a single go. Okay, so ma'am, I am done.
Okay, sir. Thank you, sir. Thank you for the very interesting session, and I think this must have been very useful for the young the scholars and the academicians also. It will help them to move in the direction of data science, or it will be helping them to promote the students to move in that particular direction. Thank you, sir. Thank you very much.
Thank you, ma'am.
The attendance link has been shared on the chat window. You are requested to please submit the attendance.
Is today's session over, ma'am?
Yes, sir. Today's session
Okay.
is over.
Okay.
Thank you.
अपने कंप्यूटर साइंस में क्या बीटेक में यार अधिक से पता चलेगा भाई क्योंकि सारा फाइनल डेटा उधर का इधर का कॉम्बिनेशन ना अजीब सी बात है। हाँ, क्योंकि एडमिशन वही कर रहा है ना नीचे, तो इसीलिए ये रहता है कि उसी के पास फाइनल करते हैं। आपके पास नंबर है इसका? प्रेम का इंतजाम हो गया।